This video is for lesson 40-2, using the addition rule for mutually exclusive events. Learning goals are to figure out the meaning of mutually exclusive, use Venn diagrams to represent these, and use the addition rule from the last lesson to calculate some more probabilities. On the screen we have the definition of mutually exclusive events. They are events that can't happen at the same time. They have no outcomes in common. Here's an example. Let's say we roll a die with the faces numbered 1 through 6, and we roll only one time. One event is that we get a number less than 3. Another event is that we get a number greater than 4. These are mutually exclusive because these can't happen at the same time. You can't roll a number that's less than 3 and at the same time it's greater than 4. Another example of mutually exclusive events would be flipping a coin once. Getting a head is one event, getting a tail is another event. They're mutually exclusive. You can't get a head and a tail at the same time on one flip of a coin. On the next page you'll see a Venn diagram, and we've been using Venn diagrams to create a visual image of our different probability situations. Let's show mutually exclusive with a diagram. Do you see the difference between this Venn diagram and all the previous ones we've drawn? The circles do not overlap. When event A and event B are mutually exclusive, they cannot happen at the same time. Therefore, we don't want to have any overlapping region in the diagram. Question 4. If A and B are mutually exclusive, what is the probability of A and B? And the answer is 0. Now go to the next page and take a look at number 5, which shows the addition rule from the previous lesson. Here's that rule that we used in the last lesson. The probability of A or B happening can be found by taking the probability of A, adding the probability of B, and subtracting the probability of A and B. But if A and B are mutually exclusive, this part is 0. We just did a question where we had that. So we could rewrite the addition rule specifically for mutually exclusive events as you see in the box. It is lacking that subtraction portion. That's unnecessary to have in the formula if events A and B are mutually exclusive. But you have to put some thought into the situation you have to decide if the events are mutually exclusive or aren't mutually exclusive, so that you're using the correct version of the formula. Now go to the check your understanding question. Number 6, describe 2 events that are mutually exclusive. I'm going to pause the video for you to think of an idea that you're willing to share with the class. So 2 things that you can think of happening, but they cannot happen at the same time. Now number 7, describe 2 events that are not mutually exclusive. Again, let me pause the video. Try to come up with an answer that you're willing to share with the class. What are 2 things that could happen, and it's possible that only one of them happens, or only the other one happens, or they both could happen at the same time? Let's summarize. For the past several lessons, we've been investigating probability of particular events happening, and sometimes we've been interested in the case where more than one event could happen. When 2 events cannot happen at the same time, they're called mutually exclusive, and the addition rule is modified so that there's no subtraction portion where you're subtracting the probability of A and B. All you need to do to find a probability with the addition rule is add the probability of A and the probability of B.